derivative. Recall the function f is increasing on the interval when the derivative is greater than 0. If the function f is decreasing, then the slope or the derivative is less than 0. F double prime is what we're going to talk about today. That's the second derivative of the derivative f prime. We have if f prime of x, the first derivative, is greater than 0, then the derivative, second derivative, will also be greater than 0. If the derivative of the function is less than 0, then the second derivative will also be less than 0. So here we have some more notation: f of x, f prime of x, f double prime of x, and y. You can have y prime, y double prime, and you could have these as well if we're using dy over dx. So the first graph is concave up when x is increasing. So it's concave up when our x values are increasing, our y values are also increasing, so the slope is positive. So f prime is positive and f prime is increasing when f double prime is greater than 0. So as the function increases, the rate of change is increasing, which means the slope of the tangent line at each point gets steeper. The rate of change increases more rapidly. Concave down when the function is increasing, the slope of the derivative is positive because this is increasing, the y values are increasing, the x values are increasing, but the rate of change is decreasing, so f double prime is less than 0. As the function increases, the rate of change is decreasing, which means the slope of the tangent lines get flatter. The rate of change increases more slowly. Increases, but it's increasing at a slower rate. Concave up when f of x is decreasing, so we're concave up, but our y values are decreasing. The slope is negative, but the rate of change is decreasing to 0, then f double prime is greater than 0. As the function decreases, the rate of change is decreasing, which means the slope of the tangent line at any point gets flatter. The rate of change decreases more slowly. Concave down, when f of x is decreasing, the slope or derivative is negative. That means f prime is less than 0. F prime of x is increasing, then f double prime is less than 0. So concave down is going to be less than 0 for the second derivative. Concave up, the second derivative will be positive. As the function decreases, the rate of change is increasing. It's slow here, and then gets faster and faster and faster, which means the slope of the tangent line at each point gets steeper. The rate of change increases more rapidly. If f double prime is greater than 0 on an interval, then f prime is increasing and the graph of f is concave up on that interval. If f double prime is less than 0, then the function is concave down on that interval. And here's an example on page 114 that talks about the value right here is called it's really called an inflection point. We haven't talked about that yet. Before the t value on the horizontal axis, f of t is concave up. So I'm concave up, and then right here I make a change, and now we're concave down. So f prime of t is increasing when the function is concave up, and f double prime is greater than 0. As t is labeled, the t value is labeled, the rate of change is steepest, so that is where the total number of units sold increases fastest. Also, at the labeled t value, concavity of the function changes. So we're going to look at our same example that we had before, and then here you're going to be able to determine where it's concave up or concave down. So if I'm traveling from here to point 903, the graph is concave down. It's also concave down here, and then it becomes concave up. At some point in time, between this point and this point, concavity changes. So we're concave down, and then we go to concave up. There's no concavity at maximum or minimum points. The derivatives are negative from 0.903 to 4.431, but the rate of change begins slowly and then speeds up and then slows down again. So we have, here we are at 0, it's getting faster, 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 and then it starts slowing down till we get to 0 again. From 4.31 to positive infinity, the derivatives are positive, and the graph increases past that value. The slopes increase more rapidly, so the graph is concave up at this point. The functions are as follows. F of x is the cube function, f prime is the squared function, and f double prime would be the linear function. So you'll have to look in your book and go through these, but look at the table. Is f prime of x positive or negative? Well, let's look at the t values. What's happening to my x? It's increasing. What's happening to the y value, or the output value, w of t? It is decreasing. So we have a decreasing divided by an increasing. That makes the f prime negative. Does this table represent a function that is concave up or concave down? Well, you have to look at the slopes. Are they increasing or decreasing? The slopes are decreasing, but at a decreasing rate. That means that the difference here is greater than the difference over here. So it's decreasing at a decreasing rate, so the function is concave up. You have to look in your book for number 20, and the function, you look at only what the function is. The function at a is negative, the derivative is 0, the double prime, second derivative, is positive. So go over that, just make sure you understand that. If you have any questions, please email me. Number 23, here we're going to create the tangent line. So we have f prime of 5 is equal to 2, and these are given values. So f double prime is less than 0 when we are greater than x, when x is 5. It's concave down. So we're going to look at this, and then we've already talked about how to create the linear approximation equation, which is the new tangent line. So the point on the tangent line would be 724. So the point on the graph should be less than 24. So C, in this particular case, is the only possible choice.